Chapter 15: The Nature of the Solar System. Greek astrologist Claudius Ptolemy is credited with developing a model of the universe known as the Ptolemaic system. The westward drift is called retrograde motion. This motion results from the combination of the motion of the Earth and the planet's own motion around the Sun. Because Earth has a faster orbital speed than Mars, it overtakes its neighbor. Ptolemy was able to propose that the planets orbited on small circles known as epicycles, revolving along large circles known as difference. The Ptolemaic model soon dominated Europe as the correct representation of the heavens, which created problems for anyone who found it lacking. Nicholas Copernicus was the first great astronomer to emerge after the Middle Ages. He constructed a heliocentric model for the solar system, with the Sun at the center and the planets orbiting it. However, he retained a link in the past and used circles to represent the orbits of the planet. Because of that, he was unable to predict the future locations of their planets accurately. The discovery that the planets actually have elliptical orbits occurred around the 17th century is credited to Johannes Kepler. The greatest contribution of the Copernican system to modern science is its challenge of the primary of Earth in the universe. Tycho Brahe persuaded King Frederick II to establish an observatory in Copenhagen, which he used for 20 years to systematically measure the locations of the heavenly bodies in effort to disprove the Copernican theory. Tycho didn't believe in the Copernican model because he was unable to observe an apparent shift in the position of stars that should result if Earth traveled around the Sun. The apparent shift of the stars is called stellar parallax, and today it is used to measure distances to the nearest stars. Tycho was forced to leave his observatory with the death of the King of Denmark. He moved to Prague, which he acquired Johannes Kepler before he passed away. The data Tycho collected to refute the Copernican view of the solar system would later be used by Kepler to support it. Johannes Kepler devised 3 basic laws of planetary motion. In 1609, Kepler proposed his first 2 laws of the planetary motion. The first one was the path of each planet around the Sun, while almost circular is actually ellipse, with the Sun at one focus. The second one was each planet revolves so that an imaginary line connecting it to the Sun sweeps over equal areas in equal intervals of time. This law of equal areas geometrically expresses the variations in orbital speeds of the planets. Then in 1619, Kepler published his third law in The Harmonies of the World. The orbital periods of the planets and their distances to the Sun are proportional, is what's stated as the third law. The latter yardstick is called the astronomical unit and is equal to about 150 million kilometers. Kepler's third law states that the planet orbital period squared is equal to its mean solar distance cubed. Galileo was the greatest Italian scientist of the Renaissance. With the telescope, Galileo was able to view the universe in a new way, including many important discoveries that supported the Copernican view of the universe. Included the discovery of Jupiter's 4 largest satellites, or moons, the discovery that the planets are circular disks rather than just points of light as was previously thought. The discovery that Venus exhibits phases just as the Moon does, and that Venus appears smaller when it's in full phase and thus farther from Earth. The discovery that the Moon's surface is not a smooth glass sphere, as ancients had proclaimed. The discovery that the Sun had sunspots, dark regions caused by slightly lower temperatures. In 1637, Galileo became totally blind, but yet completed his finest scientific work that later allowed Galileo's works to be published. Sir Isaac Newton was considered one of the greatest geniuses to ever exist due to many accomplishments in mathematics and physics. Newton formalized inertia as his first law of motion. He was the first to formulate and test the law of universal gravitation. It states that everybody in the universe attracts every other body with a force that is directly proportional to their masses and inversely proportional to the square of the distance between them. The law of gravitation also states that the greater the mass of the object, the greater its gravitational force. With his laws of motion, Newton proved that the force of gravity, combined with the tendency of a planet to remain in straight-line motion, would result in a planet having an elliptical orbit, as established by Kepler. The nebula theory proposes that the Sun and planets formed from a rotating cloud of interstellar gases and dust called the solar nebula. Repeated collisions resulted in most of material clumping together into larger chunks that eventually became asteroid-sized objects called planetesimals. Through repeated collisions and accretion, these asteroid-sized rocky bodies combined to form the 4 protoplanets in Mercury, Venus, Earth, and Mars. The planets fall into 2 groups based on location, size, and density: terrestrial and Jovian planets, also known as the inner and outer planets. The terrestrial planets are dense, having large cores of iron and nickel, while the Jovian planets have small, solid rocky cores. The Jovian planets have very thick atmospheres, compared mainly of hydrogen and helium, while the terrestrial planets have relatively meager atmospheres, composed of carbon dioxide, nitrogen, and oxygen. Solar heating, also known as temperature, and gravity explain these significant differences. Airless bodies developed where solar heating is strong and or gravities are weak. Small bodies have a better chance of losing their atmosphere because of the gas molecules that are more energetic and need less speed to escape their weak gravities. The speed required to escape a planet's gravity is called escape velocity. Large impact craters result from collisions with massive bodies, such as asteroids and comets. Because weathering and erosion are almost non-existent on the Moon and Mercury, evidence of their cratered past are clearly evident. Much of the material expelled, called ejecta, lands in or near the crater, which it accumulates to form a rim. Earth's moon is the largest moon relative to its planet, and its composition is unique in the solar system, about the same as the composition of Earth's mantle. The moon likely formed due to a collision between a Mars-sized protoplanet and the early Earth. The bulk of the protoplanet's iron core was incorporated into Earth, while its rocky mantle material spun off to make the moon. 2 types of topography dominated the lunar surface: light-colored lunar highlands, or terrae, dominated by old glaciers, pulverized by massive bombardments; darker lowlands, called maria, which are blanketed by younger flood basalts. Both the terrae and maria are partially covered by a layer of fine material called lunar regolith, produced by micrometeorite bombardment. Mercury is the planet closest to the Sun because it has a very thin atmosphere and its rate of rotation is extremely slow. The temperature on the surface varies from less than -103 degrees Celsius at night to 427 degrees Celsius during daylight hours. Venus, the second planet from the Sun, has a relatively dense atmosphere that is dominated by carbon dioxide. The resulting extreme greenhouse effect produces surface temperatures around 450 degrees Celsius. The photography of Venus has been resurfaced by active volcanoes. Mars, the fourth planet from the Sun, it has about 1% as much atmosphere as Earth and is relatively cold. Mars appears to be the closest planetary analog to Earth, showing surfaces evident of rifting, volcanism, and surface modification by flowing water. The lava accumulates in a single cone rather than forming a long chain of cones, as exemplified by the Hawaiian Islands. Jupiter is the fifth planet from the Sun. Convective flow among its three layers of clouds produces its characteristic banded appearance. Persistent giant rotating storms exist between these bands. Many moons orbit Jupiter, including Io, which shows active volcanism, and Europa with its icy shell. Saturn is the sixth planet from the Sun. Like Jupiter, it is big, gaseous, and endowed with dozens of moons. Some of these moons show evidence of tectonics, while Titan has its own appearance. Saturn's well-developed rings are made of numerous particles of water, ice, and rocky debris. Uranus is the seventh planet. Like its twin Neptune, it has a blue atmosphere dominated by methane, and its diameter is about 4 times as much as Earth's is. Uranus rotates sideways relative to the plane of the solar system. It has a relatively thin ring system and has at least 5 moons. Neptune is the 8th planet and the farthest planet away from the Sun. It has an active atmosphere with fierce winds and giant storms, and it has one large moon, which is called Triton, which shows evidence of cryovolcanism, which describes the eruption of magmas derived from the partial melting of ice instead of silicate rocks. Small solar system bodies include rocky asteroids and icy comets. Both are remnants from the formations of the solar system, or fragments from later impacts. Most asteroids are concentrated in a wide belt between the orbits of Mars and Jupiter. Some are rocky, some are metallic, and some are basically piles of rubber loosely held together by their own weak gravity. Comets are dominated by ices that are dirtied by rocky material and dust. They originate in either the Kuiper belt, located behind Neptune, or the Oort cloud, a spherical shell around the outermost solar system. When the orbit of a comet brings it through the inner solar system, solar radiation, known as sunlight, causes its ice to begin to vaporize, generating the gaseous envelope around the comet's nucleus and its characteristic. A meteoroid is debris that enter Earth's atmosphere, flaring briefly a meteor before either burning up or striking Earth's surface to become a meteorite. Asteroids and material lost from comets as they travel through the inner solar system are the most common source of meteoroids. Dwarf planets include Ceres, located in the asteroid belt, dwarf planet Pluto, Eris, and a Kuiper belt object. They have spherical bodies that orbit the Sun, but are not massive enough to have cleared the orbits of debris. And that was Chapter 15, The Nature of the Solar System, wrapped up all together. Thank you.